Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for finding a peak element in an array. Let's look at the problem description. A peak element is an element that is strictly greater than its neighbors. Okay, so we are given a zero indexed integer array and we have to return the index of the peak element in that array. Okay, so if the array contains more than one peak element, we can return the index of any of the peak. So we can assume the previous neighbor of the first element and the next neighbor of the last element are minus infinity. And we have to write an algorithm with order of log n time complexity. Let's take a look at the example 1. So the given nums array has 4 elements 1, 2, 3, 1, and in this number 3 is greater than its neighbors. So we have to return the index of the 3, which is 2. And in the case of example 2, the given nums array has 7 elements 1, 2, 1, 3, 5, 6, 4. Okay, so in this array number 6 is greater than its neighbor, so we have to return the index of number 6, which is 5. The constraints for this problem are the length of the array is ranging from 1 to 1000 and the value of the individual elements in the array is ranging from minus 2 to the power 31 to 2 to the power 31 minus 1, and the consecutive elements are not equal. Okay, let's look at the approach to solve this problem. The given input array has 4 elements 1, 2, 3, 1, and the number 3 is greater than its neighbors. So we have to return the index of the element 3, which is 2. Okay, so the brute force approach is we can traverse the input array sequentially, and each iteration we can compare the current element with its previous neighbor and the next neighbor. Whenever we find an element which is greater than its neighbors, we can return that index. So the time complexity of this approach is order of n, but we are expected to solve this problem with order of log n time complexity. So we can utilize the binary search technique to solve this problem in order of log n time complexity. Okay, each iteration we compute the index of the mid element in the array, and then we can compare that mid element's previous and the next neighbors. If the mid element is greater than its previous and next neighbors, then we can return the mid index as the output. Okay, so if it is less than its neighbor, then we have to proceed the search in the part of an array where the largest element is present. For example, in this case, the first iteration, the mid index is 1. Okay, so when we compare the value of the mid with the previous neighbor and the next neighbor, we see the next neighbor is larger than the mid element. So in that case, we have to process the second half of the array starting from mid index plus 1. So in this case, in the next iteration, we have to process this half of the array. Okay, in case if the 3 is present on the left side, then in the next iteration we have to process the first half of the array. Like this, each iteration we choose the half which contains the larger element and repeat it until the start and end pointers meet each other, or we find an element which is greater than its neighbor. So that's what I have written here. So first we initialize the first and last index with the value index of the first element's value and the index of the last element in the array. And then we initialize the start, end and mid indexes. The start will point to the first element index and the end point to the last element. The mid is initialized with -1. Okay. Then we check whether the first and last are equal. That means the input array has only one element. In that case, we can return the start index as the output. Otherwise, we traverse the nums array until the start and end indexes cross each other. Each iteration we compute the index of the mid element, and there are 3 cases needs to be handled. One is the mid element is not equal to the first and last element of the original input array, and the other case is the mid element is equal to the first element of the original input array, and then the mid element is equal to the last element of the input array. In the first case, we can safely access the previous and the next neighbor of the mid element. Okay, so we check whether the mid element's value is greater than its neighbors. In that case, we return the mid. Otherwise, we check whether the previous neighbor is greater than the mid element. In that case, we have to update the end pointer with mid -1. Otherwise, we update the start pointer with mid +1. Next case is the mid index is equal to the index of the first element. So in this case, we compare the mid element's value with its next neighbor. If the mid element is greater than its next neighbor, then we return the mid index as the output. Otherwise, we update the start pointer with mid +1. The third case is if the mid index is equal to the index of last element. So in this case, we compare the value at mid index with its previous neighbor. If that is true, we return the mid as the output. Otherwise, we update the end pointer with mid -1. We repeat this until the start and end indexes cross each other. Okay. Finally, we return -1 if we are not able to find the mid index which is greater than its neighbors. Let's look at the flowchart. The input for this procedure is nums array. First, we initialize the variable first, last, start, end, and mid. The first is initialized with index 0. The last is initialized with the index of the last element in the input array, and the mid is initialized with -1. Then the start is initialized with the first index, and the end is initialized with the last index. Then we enter the for loop. So this for loop runs until the start and end cross each other. Each iteration we compute the index of the mid element, and then we check whether the mid is not equal to the first element index and last element index. Okay, if that is true, then we compare the element present in the mid index with its neighbors. Okay, so if the mid index is, if the mid element is greater than its neighbor, then we return. Otherwise, we check which neighbor is greater. If the previous neighbor is greater than the mid element, then we update the end pointer with mid -1. If the next neighbor is greater than the mid element, then we update the start pointer with mid +1. Once this is updated, then we continue the search. If the mid index is equal to the index of the first element, then we compare the mid element's value with its next neighbor. Okay, so if the mid element is greater than the next neighbor, then we return. Otherwise, we update the start pointer with mid +1. Okay, so this is the third case where the mid index is equal to the index of the last element in the input array. Okay, so in this case, we compare the mid element with its previous neighbor. So if the mid element is greater than the previous, then we return. Otherwise, we update the end pointer and then we repeat the search. Finally, we return the value of the mid index as the output. Let's move on to coding. First, I initialize the first variable with the index of first element of the array and the last variable with the index of the last element of the input array nums. Next, I check whether the first and the last index are equal. That means it is a single element array. So we return the first index as the output. Next, I initialize the mid index with -1, and then I initialize the start pointer with the first value of the first variable and the end pointer with the value of the last variable. Then I write a for loop. This will run until the start and end pointers cross each other. Each iteration I compute the mid index value by adding start plus n minus start divided by 2. Then I check whether the mid index is not equal to the index of first element in the original input array and index of the last element in the array. If that is true, then I compare the value at mid index with its previous and next neighbors. If the value at mid index is greater than its neighbors, then I return the mid index as the output. Otherwise, I check whether the value at mid index is less than its previous neighbor. Then I update the end pointer with mid plus 1. Otherwise, I update the start pointer with mid plus 1. Basically, we are selecting the second of which contains the larger element than the mid element. The next case is if the mid index is equal to the index of first element in the array. So in this case, I compare the value at mid index with its next neighbor. If the mid index value is greater than the value at mid index is greater than the next neighbor, then I return mid. Otherwise, I update the start pointer with mid plus 1. Next, I check the third case. This is if the mid index is equal to the index of last element. So here I compare the value at mid index with its previous neighbor. If it is greater than its previous neighbor, then I return the mid index. Otherwise, I update the end pointer with mid minus 1. Finally, I return the mid index as the output. Next, I am going to run the test cases. All the tests passed. Next, I am going to submit this program. Cool, this program is accepted. Next, I am going to do the code walkthrough with sample input. Input array nums have 4 elements 1, 2, 3, 1. In this array, number 3 is greater than its neighbors. So we have to return the index of the number 3. So the index of number 3 is 2. So the expected output is 2. So first we initialize the variable first with index of the first element and last with index of the last element. So for this case it is 0 and 3. Next we check whether the first and last are equal. In this case it is not. So we go ahead and initialize the mid index value with minus 1 and then we initialize the start and end pointers with first and last variables value respectively. So start is 0, end is 3 and mid is initialized with minus 1. Then we enter the for loop. So this will run until the start and end pointer cross each other. The start is 0 and end is 3. So we enter the for loop. In the iteration 0, we compute the value of the mid index. So start plus n minus start divided by 2. So start is 0 and 3 minus 0 divided by 2, we have 1. So the mid index value is 1. So the number 2 is located at index 1. Okay. Then we compare whether the computed mid index is not equal to first and not equal to the last index of the original input array. So in this case 1 is not equal to 0, 1 is not equal to 3. So we go ahead and check the value at mid index with its previous neighbor and its next neighbor. Number 2 is greater than its previous neighbor, but it is less than its next neighbor. Okay. So in that case, we update the start index with mid plus 1. So when we leave this iteration, the start pointer will be set with 2. So mid plus 1 is 2. And in the iteration 1, when we enter, the start pointer is 2 and end is 3. Okay. So we compute the mid index by adding 2 plus 3 minus 2 divided by 2. So this is 0. So the mid index will be 2. So it points to the element 3. Okay. Then we check whether the mid is not equal to first and mid is not equal to last. In this case it is true. So we go ahead and compare the element at mid index with its neighbors. Okay. So in this case the value 3 is greater than its previous neighbor and the current neighbor. So we return the mid as the output. So in this case mid is 2. So the output will be 2, which is an expected output. Next I'm going to do the time and space complexity analysis for this solution. The time complexity of this procedure is order of log n. Okay. Let's take a look at the case 1. So the nums array has 4 elements. So for this case, this for loop performs 2 iterations as per the previous code walkthrough. So which is equal to log 4. In case 2, the input array has 7 elements. For this case, the for loop performs 2 iterations, which is log 7 base 2. So if there are n elements, the for loop performs log n iterations. So basically we found the peak element in log n iterations. That's why the time complexity is order of log n. Space complexity is order of 1 because no additional space allocated in terms of input size. So we use few variables which are independent of the input size. So that's why the space complexity is order of 1. Thanks for watching this video. Have a great day.